Hello everyone. Congratulations to all of you because we have created the history and now our Chandrayaan 3 has been reached to moon and it's a proud moment to all of us. So let's celebrate and let's also cover the new topic. As you can see on my screen, I already written something over here regarding recursion and backtracking. Backtracking is the second part and now we are going to focus on the recursion. So, if someone want to know, learn about the Fibonacci, the basic recursion technique, they can watch my last three lectures. I have implemented the Fibonacci using the recursion, simple recursion, using the memorization, using the tabulation. Okay, so if someone is looking regarding the definition part of the recursion and they want to define it or something. So recursion is nothing, it's a particular tool or process that execute the similar step again and again by calling the same function until your base or end condition not met. So here what happened, your each call is going to use the separate stack memory, and when that call return the value or return any value, it will release that particular stack memory. So one thing you have to remember that your base condition should be very strong and should be very careful. If you are applying the base condition, very careful, it's very crucial because it is very crucial because if it is not if your base condition is not good and it is not satisfy all the scenario, then your program can be through the out of memory exception, stack overflow something. So all things can be happen and your also program all pod or application can be crash. Yeah, so there are one I already covered. Now it is the longest common subsequence. So here we are going to cover the longest common subsequence using the recursion today. Okay. So first we have to focus what is the subsequence here. Uh, so if you are going to write any program, so just any regarding any problem, so just focus on the problem, what type of problem it is, read problem carefully, and learn and also remind all the base thing regarding that problem. Okay, base thing. So what is the subsequence here? So let me explain this. What is the subsequence? Subsequence, like if you have a string like a b c. Okay, if you have a string a b c and you want to find the subsequence of this a b c. So how you can find? There is a formula as well. You can use that formula directly, but I'm not going to tell that formula until I'm going to until uh, first I will make you understand, then I will tell you the formula how can find that particular, how can if you want to find quickly the subsequence, so you can apply that formula easily and you can find that. Okay, so here is ABC. So you want to find the subsequence also. If there is any blank string, so it's this blank string is also the subsequence of ABC. Okay, this A is also the subsequence of ABC. This B is also the subsequence of ABC. This C is also the subsequence of ABC. This AB is also the subsequence of ABC. But this BA is not the subsequence of ABC because BA is not maintaining the order, right? So you have your BA is not the subsequence of ABC, correct? Okay. Now let's see. We can write the AC as well. AC is the subsequence of ABC. We can write BC as well. BC is also the subsequence of ABC. We can write ABC. ABC is also the subsequence of ABC. So if you count it, 1, 2, 3, 4, 5, 6, 7, 8. So total is 8 subsequences there. So if we formulate it, you can use the 2 to power n, where n is the number of character, n is the number of character of a string, right? So you can formulate it like that. So now we are going to find the longest common subsequence. So suppose that now you got on now you already got it, what is subsequence. Now we need to find the longest common subsequence. So longest common subsequence, like if we have the second input string, if we have the second input string a c, and we want to see that first input string is abc and second input string is ac, perfect. So here your AC second input string, check that it is the subsequence of ABC. Yes, it is the subsequence of ABC. Your A is matching and your C is matching, and it is also maintaining the order. Okay. So remember this subsequence cannot be consecutive, but they will maintain the order. Okay. So here how many character inside the subsequence? One and two. So the longest character will be one, two. Okay, so it will return always the 2. Perfect. Okay, so let's solve this problem inside the code. But before going to code, we have I am going to explain a diagram that I already created. Okay, so you can see on my screen there is a beautiful diagram over here. So this is a tree data structure that particular things are using. Okay, so how we are going to run this? Yeah, first we have to understand this diagram. So there are two input. There is a LCS method, longest common subsequence method. They are having the parameter ABC. This is first input string. This is second input string, and this is our index that is starting from the zero. Okay, so I is equal to zero. This is for ABC, and J is equal to zero. This is for AC, second input string. So let's see. First, it is now it is going to break two child. Okay, so the two node will open here. So now check that there is one condition. If ai is equal to bj, I value is 0, j value is 0. So a0 is equal to b0, a0 having the a, b0 having the a. So this condition is going to be true. So the compiler your process, it will not, so this node will not execute. Okay, so here compiler will not go, you can say. Yeah, at runtime. So your processor will not process this particular node. Okay, so try to understand here. Your this condition is getting true over here. Okay, so it will go inside this node and it is already returning 1 plus LCS. This method, again this method is calling using the ABC AC, I is equal to 1, j is equal to 1. So what is happening here? I plus 1 and j plus 1. Okay, so we are calling here already I and j we are sending, and this condition is getting true. Then we are calling with I plus 1 and j plus 1. Okay, so the I having the value 1 and j is having the value 1. So now we check it again. A1 is equal to b1, a1 having the b and b1 having the c. So this condition is not going to be true. So this particular node will not be processed. So it will go inside this right direction. So this condition is going to be true because ai a1 doesn't equal to b1. So that's why we are going to process this max now. This is remember this, when it is not equal, then we will use this logic. Max LCS, longest common subsequence, having to separate ABC AC, this particular two strings. Now here you see I plus 1, we are doing the I plus 1. Previous I value was 1, so now it is getting over here 2. So I plus 1 is equal to I plus 1 comma j. We are simply passing say j here in the first LCS method. The second LCS method we are passing I simply and we are increasing the j. So whatever the output, suppose that this method is coming 0, this method is coming, this method is returning 0, this method returning 1. So 1 comma 0, max value is 1. So this particular node will return 1 above side. But let's check first. So this LCS I is equal to 2, j is equal to 1. So let's see I it's mean A2 is equal to B1. A2 is equal to B1. A2 having the C and B1 having the C. So this condition is going to be true here. So if you this condition is going to be true, then the same is expression 1 plus LCS ABC AC I plus 1 and J plus 1 here. J plus 1 I think it's by mistake. J plus 1 it should be here. Always carefully notice it. So it should be J plus 1 also, so like that. So but one thing you remember, I is equal to 3, it is going to be I is equal to 3. So as in our particular our first string ABC having the only till second index, it is not having the third index, so your base condition will return the 0 for this method. Base condition will return the 0 because it is increasing your length size. Okay. Right, it is so your base condition is written 0, so 1 plus 0, 1 plus 0 is equal to 1. So now this particular node will return 1 over here. So this method returning 1. Now let's see this method what it is returning. So the ABC AC I is equal to 1, J is equal to 2. So here we are increasing the J. So as you can see one thing, that J is equal to 2. So on the second string, we have only the first index, 0 and 1 index. It is not having the second index. Okay. So this particular method will also return the 0. So this particular method will return the 0 and this method was returning 1. So 1 comma 0 will be 1 comma 0. Which one is maximum? 1. So this particular node will return again 1 to the root node, not root node, to the parent node, and this 1 plus 1 will be 1 will become 2, and this this particular child node will again return the 2 to the root node. So this root node will return the 2 to the main program. Okay. Now you got this condition. And when suppose that your first AI and BJ is not matching, when I is equal to 0, J is equal to 0. So always this particular node will expand in that time. What you guys try to do it on your copy, and try to just take two inputs, any two strings, and try to draw this diagram on your copy. And whatever the final input, final output is coming over on this route, check that, then try to write the program using this logic. Okay. Then you can understand it better, more better. So now let's write the program. Now let's write the code. Okay, in Java. Yeah. So as you can see, I have already the method, but I need to write that particular logic inside that. So let's write the first base code. If I equal to I and one dot length, or j equal to base for the second string, I and 2 dot length, right? So what we will return? We will return the 0 from here in that case, because it is increasing the size. Now if the the condition for the left child, I and one dot caret I equal to I and one 2 dot caret j. Now let's write. So we are going to assign it inside the length, right? And write the logic, the same logic, 1 plus longest common subsequence I and 1, I and 2, I plus 1 and j plus 1. Perfect. Now check the else part. If that condition is not correct, then what will happen? We will take the math.max. Let's check that ln, and now check the math.max. Here longest common subsequence I and 1. Here in first particular node we are increasing, here first method call we are increasing here only the I, not j. And in the second we are going to increase the j, not I. Perfect. Okay. So now let's return length from here. Okay. So, so this is your complete code. Now let's run this program. Now let's run this program from here. What will happen once again? Let's run this. Yeah. There is some error over here. What error is there? Okay, this is the error, man. Once again, let me run it again. A B first string A B C D E F, and second string A C E F. So now if you see, this is returning 4 here, and our total time is 29,400 nanosecond. So it is only, we are not using here optimization, we are using the simple recursion approach. So in next video I will explain the recursion. Okay, recursion with optimization using the some dynamic memoization or tabulation technique, right? Okay. So one thing more, actually. So I'm going to show you the topic related, that I will explain in our few playlist. I will also create a playlist regarding the Java. So if someone is interested to learn inside the Java, actually, so they can learn from here. So as you can see, these are the topics I will explain. So basics of Java, particular and class object types, and this is Java basics, packages, data types, what is data type, variable, const, literal, methods, constructor, modifiers, statics. So these all the things I will explain my final inner class hooks concept. Okay, polymorphism, abstraction, garbage collection, and input output stream, and collection for framework serialization. All the things, expect exception handling, Java annotation, reflection, Java array, string buffer, Java threading, and as well design pattern and streams as well. Okay, for the Java 8 and also some Java 14 feature and 17 feature, we'll explain. Okay, okay. So happy learning, and let's meet in next video with the optimization technique of longest common subsequence. Thank you.